Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel with practice problems is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam FM on financial mathematics. You are given the following information about a loan of L that is to be repaid with a series of 16 annual payments. The first payment of 2,000 is due 1 year from now. The next 7 payments are each 3% larger than the preceding payment. From the 9th to the 16th payment, each payment will be 3% less than the preceding payment. The loan has an annual effective interest rate of 7%. Calculate L. This is the amount of the loan. And here is the solution. So the amount of the loan will be simply the present value of all the payments that are made to repay it. The present value of the first 8 payments is 2,000 times 1.07 to -1, so discounted at 7% of 1 year. Then 2,000 times 1.03 times 1.07 to -2, and so on, through 2,000 times 1.03 to the 7th times 1.07 to the 8th. That's the first 8 payments. So we rewrite it as 2,000 times 1.07 to -1. That's the first payment, and then times 1, because you get the first payment by multiplying this by 1, plus 1.03 over 1.07, because the 2,000 is multiplied by 1.07, but it's discounted over 1 more year. Then plus 1.03 over 1.07 squared, and so on up to 1.03 over 1.07 to the 7th. That expression in the large parentheses is a partial sum of a geometric series. So we use the formula for the sum of such a partial sum of a geometric series, and that's equal to 1 minus 1.03 of 1.07 to the 8th, which is a power of 1 more than the 7 over here. So if this was 1 plus r squared and so on through r to the nth, then this is 1 minus r to the n plus 1, and divided by 1 minus r, where r is the ratio of that series. And the ratio here is 1.03 over 1.07, because you get every next term by multiplying the previous term by 1.03 over 1.07. And this, what we have now, we just calculate. And this is approximately 13,136.41. The present value of the second 8 payments is 2,000 times 1.03 to the 7th times 0.97, because they go down by 3% now, times 1.07 to -9, because it's paid at time 9, so discounted to time 0, plus 2,000 times 1.03 to the 7th times 0.97 squared, times 1.07 to a -10th, and so on. And the last term will be 2,000 times 1.03 to the 7th times 0.97 to the 8th times 1.07 to a -16. We factor out 2,000 times 1.03 to the 7th times 0.97 times 1.07 to a -9, and then this is all multiplied by a partial sum of a geometric series, where the ratio is 0.97 over 1.07. So we use the same formula, and this partial sum is equal to 1 minus 0.97 over 1.07 to the 8th divided by 1 minus the ratio, so 1 minus 0.97 over 1.07. And that's approximately equal to 7,552.22. And the total of the two and the amount of the loan is approximately 20,688.63, which is answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries and the solution is mine. Good luck in your studies and good luck on the test.